This is a block of birch. Hold it over a page, and you can read the words underneath. Still wood. Same grain, same growth rings, same tree. It isn't a coating, and it isn't a thin slice of wood laid over glass. It's a solid block, and what goes in one face comes out the other. And it isn't new. It's been sitting in the materials journals for 10 years. Something had to be dissolved out of that plank first. The same something that gives every tree on Earth its color. Two teams, an ocean apart, landed on it within months of each other. Neither of them was first. Hold it up to a face, and the face vanishes. It exists. It works. And there is not one pane of it in your house. So what is it waiting for? Start with the line everyone quotes. Transparent wood is stronger than glass. That's true, and also the most misunderstood sentence in the whole subject. Glass is harder than this. Scratch them both and the glass wins. Glass is stiffer too. Push on a pane and it barely bends. So what does stronger mean here? Bending. Lay a strip across two supports, press down on the middle, and measure the force it takes before it fails, and what it does on the way down. Glass is brittle. A crack starts at one microscopic flaw on the surface and runs the whole way in a few thousandths of a second. Wood doesn't do that. In published bending tests, transparent wood absorbs roughly 10 times the energy a comparable pane of glass absorbs before it breaks. And breaks is the wrong word for what happens. It dents. It splinters. It stays in one piece. The fibers are still in there, running the length of the plank like rebar, and a crack has to snap every one of them to get anywhere. Two more numbers. It weighs about half what the same pane of glass weighs, and heat crosses it about 5 times more slowly, which makes it, on paper, a better pane than the one in your window frame right now. But every one of those numbers depends on a step nobody expects. None of it happens while the wood is still brown. A tree is plumbing. Millions of hollow tubes running root to leaf, all pointing one way, all carrying water up. That geometry is the whole reason this works. The straws are already there. Wood is two materials wound together. Cellulose, the fibers, pale and see-through on their own, and lignin, the stiff brown polymer packed between them, gluing the structure together and holding the trunk up. Lignin is why wood is brown. It absorbs light. Take it out, and what's left is a white skeleton. You do that with chemistry, usually a hot bleaching bath, a close relative of the chemistry that whitens paper pulp. The plank comes out pale, soft, and still perfectly shaped. Every tube exactly where it grew. But it isn't see-through yet. It's white, the white of paper or bone, because now it's full of air. Light hits the side of a cellulose tube, crosses into air, hits the next one, and bends every single time. Thousands of tiny refractions, and the beam scatters into nothing. So the second step fills the air back in with a clear polymer, usually an acrylic or an epoxy. And this is the whole trick. Cellulose bends light by a factor of about 1.53. The polymer bends it by about 1.5. Close enough that light crossing the boundary barely notices it's there. No boundary, no scattering. The block goes clear. Not dyed, not polished. It's chemically the same wood. It just stopped disagreeing with light. Which raises the obvious question. If the recipe is one bleach and one plastic, why isn't this 100 years old? It is, sort of. In 1992, a German botanist named Siegfried Fink published a paper on bleaching wood clear. He wasn't building anything. He wanted to see inside a plant without slicing it apart. It worked. It went into a wood science journal. And for 24 years, essentially nothing happened. Then, in 2016, two groups published within months of each other. In Stockholm, Lars Berglund's team at KTH. In Maryland, Liangbing Hu's team at the University of Maryland. The idea matched. The chemistry didn't. Berglund's group was thinking about buildings, big load-bearing panels that let light in. Hu's group pushed the optics harder, thin samples that let light in almost as freely as ordinary window glass. That turned a lab curiosity into a race. There are now groups working on it across Europe, North America, and Asia. But there's something those samples hide, and that's the reason you have never seen this in a showroom. Transmission and clarity are two different things. A millimeter-thin sheet of transparent wood lets through 80 to 90% of the light that hits it. It does not let through the image. Some scattering always survives. The polymer matches the cellulose closely, but never perfectly, and wood is layered, dense rings and light rings, over and over. So what comes out the far side is the right amount of light, pointed in the wrong directions. Put a photograph behind it, and you get a smear of color. Hold it against a face, and the face goes, which sounds like a failure. A glass window is a hole in the wall. It hands you the sun as a hard, bright disk and a blinding stripe across your desk. This hands you the whole pane, glowing evenly at about the brightness of an overcast sky. No glare, no hotspot, daylight with the edges taken off. That's a lamp, not a view, which is exactly what a ceiling panel wants to be, or a wall, or a skylight over a stairwell. And once you stop asking it to be a window, strange things start to look possible. The tubes are just containers. Fill them with something other than clear plastic, and the wood inherits whatever you put in. At KTH, they filled them with polyethylene glycol, a wax that melts a little above room temperature. As it melts, it soaks up heat without the pane itself getting hotter. It also changes how the pane looks. Solid wax scatters light, so the panel sits hazy. Melt it, and the wax matches the cellulose more closely, and more light gets through. So it sits hazier on a cold morning, brightens through the warm part of the day, and gives the heat back at night as it sets again. A wall that charges in sunlight and discharges after dark, and tells you which one by how clear it is. That is published lab work, not a product you can buy. So is the next one. Researchers have loaded those tubes with quantum dots, nanocrystals that swallow one color of light and spit out another. Feed that panel ultraviolet, and the wood itself emits wood, glowing, because the plumbing was empty and somebody filled it with something else. None of this is what's standing in the way. Three things are. None of them is physics, cost, scale, and what happens to it at the end. The chemistry is slow and it's wet. Bleaching a plank takes hours in a hot bath, and then the polymer has to be pulled all the way into the tubes under vacuum. That's fine for a sample the size of a phone. A window is a different problem, and the biggest sheet anyone has published is 40 centimeters long and a millimeter thick. Then there's the polymer itself. It's usually a petroleum plastic, which makes a sheet of transparent wood a composite, wood laced with acrylic. Composites are hard to recycle. You can't pulp it, and you can't pull the plastic back out. A window that lasts 30 years and then has nowhere to go is a hard sell in 2026, which is why the most interesting result in this field arrived in 2026. A team in Osaka published a version with no added polymer at all. Soften the cell walls with potassium hydroxide, then let the plank dry. As the water leaves, the softened walls collapse against each other and close the air gaps. Fewer air gaps, less scattering. About 70% comes through, and no plastic in it. Fully bio-based. No plastic to deal with at the end. It's one paper, it hasn't been scaled, and it hasn't been put in a wall. But it removes the one objection that was never going to be fixed by making the bath cheaper. So, is transparent wood real? Yes, since 1992, and properly since 2016. Is it in your window? Not yet, and now you know exactly which three problems are standing in between. There's a block of birch on a bench somewhere with a page underneath it. and the words are still perfectly readable. 10 years it's been sitting there. Somebody just has to be able to afford it.